give you a short lecture on high energy physics. I've been doing studies in biology and stuff, and what you discover in biology to get advanced organisms from single cell organisms, you have a fusion process, and that involves high energy. And base it on something we discovered a long time ago, something that came up in the news recently. This is from the New York Times Press. They found an old rock, oldest known drawing in a rock in South Africa, dating about 73,000 years old. And it dates beyond older than, or the earliest European drawings, abstract drawings in caves, going about 30,000 years ago. So, and there was a tribe of Homo sapiens in Africa, and what they discover on the rock is lines, intersecting lines, and what the lines represent is lightning. If you're a caveman 73,000 years ago, and you don't have the ability to read and write, and you're all hovering in caves and stuff with not a whole lot much going on except hunting, what's the biggest event out there that we know of? Well, lightning's the biggest event. You know, lightning became associated with God to the ancients. It's also the origins of religion, because we knew that cavemen knew that when lightning hit, during rains and stuff, they'd get a euphoric feeling. They felt better. They were getting the ions, the fresh ions and stuff, and became associated with God, because they didn't understand what caused the lightning, but they knew it existed. And so anything that they didn't understand, they couldn't understand, became associated with God, which is the origins of ancient religions and stuff. But these were found in the Blombos caves. There's a hidden history back there. You know, even in Africa and stuff, they can only go back so far. In Europe, it can only go back so far too. We know that 5,000 years ago, reading and writing and civilization really begins, but there's no place there in the Middle East, as far as I go, can we trace back where does civilization begin. All we know is there's a tribe in Assyria and Babylon up there in Iraq and stuff where civilization begins, but you cannot pinpoint it. There's a gap, there's a missing history, and there's a missing history in archaeology too. There's one of the books I picked up. It's by Michael Cremo, called Forbidden Archaeology. And it's a very extensive book. It's kind of hard to get people to do these kind of research. And you can tell he spent a lot of time on putting his books together, this book together. And it's an analyst of a lot of the archaeological stuff that they discovered over the years. And to him, it doesn't point to Darwin's theory of evolution. It was a lot of, he indicated that that's not our origins. But even Richard Leakey admitted that the fossil evidence didn't indicate there was a lot of missing links and a lot of gaps they could not come up with. It just didn't add up. So at least he was being honest that they didn't have that doesn't necessarily mean that the natural selection was true. But we know that lightning is associated with is the origins also the study of high energy physics, because it involves high energy. And that's one of the reasons why people started, when we started getting involved about the 1500s and stuff, they started thinking in terms of how the universe works and stuff, and science started developing and stuff. Around the 1900s or around the 1880s, somewhere around that time, they started getting into high energy physics. They knew that lightning and high energy had something to do with creation. And they did do a study in a laboratory with using a Van de Graaff generator with a bunch of different gases, and put lighting into it to recreate that primordial event. And but high energy physics is something that I think is what is also the origins of us. We know that lightning, and I talked about this in a past lecture, causes nucleosynthesis in ball lightning. It takes something you can't see, atmosphere up there, and when it goes into ball lightning, like the witch's ball, all of a sudden gas becomes visible. And we know that energy, that we are composed of energy. We also have luminescence that shows up. Our bodies are just like jellyfish. Under certain kinds of spectrometer readings, you can see the bioluminescence. Our bodies are composed of luminescent energy that we don't quite understand yet. There is a standard explanation as to what black body radiation is. But I think as time goes on and we get more advanced in technology and stuff, well, I think they're going to get more, they're going to discover high energy physics was part of our creation. Just a good example of how fast technology is changing. About 6 months ago, I did a lecture. I said that Star Trek doesn't use the air conditioners that we use. I work in heating and air conditioning. And I said, they don't use Freon. And, well, just recently, I was correct. There's an advanced version of that. They got somebody's come up with a air conditioner that uses just magnetism, and they can change the temperature by just using certain kind of magnetism that creates the cooling effects. And now you don't have to use gases anymore. Now, one of the problems they have with that technology is the cost. You know, as I said in my last lecture, it's going to require a new type of government to get some of those technologies out there, because the cost of the technology is probably going to be too high, and only a certain portion of the population ever buy one of those. But there could be eventually a government buyback program, which they use up there in New England. I think Chuck Schumer uses that up there in New York City, where you trade your air conditioning unit and your window unit in, and the government gives you back another one. And they use that back as a subsidy, and they compact all the old air conditioners and recycle them, which is a good program. So I could see eventually some of that new technology being put out there just with that program, especially even with high definition TVs. A lot of people can't afford them. You know, if you're people the investors that invested in that technology and research want their money back. So to me, the government buyback program would be a good way to get more high definition TVs into people's homes. But either way, another good example is Star Trek. You know, I said that advanced civilizations have stuff that we don't have yet. Well, that was in the 1960s. William Shatner just did a thing they struggled with Star Trek because it was a new format, and they were going to cancel the show and then they put it on the air the next year. They were going to cancel the show, put it on the air again next year, and so they did struggle some. They only had one movie before Star Trek was 2001, so it was something new to the general public during that time period. But this right here was something they pulled out of their pocket in the 1960s, and it became technology around the 1980s. So, you know, it's here again, it's advanced forecasting, but it's based in scientific data that indicates that this eventually would be possible. The reason why this is possible is because Nikola Tesla. Nikola Tesla did his own studies in high energy physics and discovered how to back in the 1930s, discovered how to broadcast signals, free energy over long distances, which created basically the first cellular tower. The only problem he had is that Thomas Edison already had electricity and stuff already out there in lines and power lines and stuff, and saw that as being a replacement for all that he'd already done. And he basically just canceled the funding for the cellular phone tower that Tesla built. He created Tesla was real bitter because he was on the verge of discovering something new, and Thomas Edison just saw his investment money going up in smoke because Tesla was talking about transferring energy over long distances, and it didn't involve what Thomas Edison already had out there. So it's kind of set things back. But eventually, this is a product of Nikola Tesla researching the high energy physics back in the 1930s. So that made this possible. So just like the recent Battlestar, I was watching Battlestar Galactica this morning, and that doesn't mean that's not been out there before. It's based in the foundations of science, in physics and engineering. You start off with a foundation, but we know there's advanced forms of those foundations. We don't live in flatland. We know that eventually we're going to walk upright, and we're going to get more knowledge, and we're going to start seeing stuff that we never have seen before as far as physics go. So we don't live in flatland. Flatland was a state that we began in, but also set a foundation for everything else in life. So, but high energy physics, they were doing a lot of studies in the 1930s. They didn't have a Fermi lab and all that stuff out there till later. But what they did do is they started putting detectors for cosmic rays and stuff up there in mountains and stuff, because they knew there was cosmic energy coming in, and they knew that there was a certain level of high energy that was coming in from around in the cosmos. Later discovered some of that was background radiation and stuff. So they set up these laboratories all over the world to measure cosmic radiation and stuff. And here's a there's one of the problems that they had in high energy physics, and it's a carryover from observations in nature, that all matter is inherently unstable, and it decays. So it's basically from watching nature. You see trees and stuff that during the fall they turn orange and yellow, and then they decay and fall off the tree, and they hit the ground and decay and become soil. And it's something that's stuck in the physicists' heads, because that's it, and it's also part of the Darwin's theory of evolution, and grounded in that was also part of the 1800s. So it's a product of observations in nature. Unfortunately, it's stuck in physicists' heads that all matter is inherently unstable, and that it has this decay. And so they stellar evolutionists attach the word decay to it, because it's observations in nature. Good example of that, we know that when our heart stops, our physical body dies. It decays and becomes carbon. I've got a list of everything, all the chemical elements of the human body, and it's, but all that decays into just carbon. But here's the thing about that. Is that always true? There's been miracle stories, great shamans like the Guru Paramahansa Yogananda. When he died, his body didn't decay. He did his last sermon, and then he went into just kind of a trance, and then and he died. And but when they 5 weeks later, when people were coming around the world to visit him, his body had decayed. So there's something happened. That is not always necessarily true, that matter decays. in other states. So there was a loophole, you know, that happened. The Vatican has stories of saints and stuff, body parts that didn't decay and stuff, that they can't explain. So that's not. It's based on observational biology and stuff. So they attach decay to it. So here's something else. Something else is that mission rate of supernova formation is that the 99% of energy is emitted as neutrinos. I look at neutrinos as information because they're round and it's like a witch's ball. We know that a neutrino is the center of an atom, and we know that anything within a witch's ball is information. It contains some kind of information. And it's throughout the universe. Even the universe is round. Single cell organisms go round. So we get it still. It all focuses on the witch's ball. You go to a Freemason's lodge. You take his compass and you do this. What do you have? You have a witch's ball. If you don't believe that Freemasons don't believe in witchcraft, they do. It just isn't promoted a lot in the lodges these days because I'm not out there. If you're looking for me out at the lodge, you won't find me because it's not, the lodge of today is not the lodge of yesteryear. But the witch's ball and the neutrino, to me, I look at it as also is a source of information out there in the universe. And so that we know that neutrinos have protons and neutrons and electrons spinning around them, which is the foundations of an atom. So there's something that orbits around the information. And but that also gets into single cell organisms and stuff too. Advanced forms of life, which are the I don't have my notepad with me. I thought I was prepared for this lecture, but I don't. But anyways, there's two forms there's advanced forms of single cell organisms, and those advanced forms are what compose us. You have to have a nucleus that holds the information to be able to do that. The other forms of organisms, single cell organisms, are the more primitive kind, or I guess the archaea, which is bacteria and your simple forms of life. Those are the oldest forms of life. And back in my last lecture, I said that ET had the ability to edit those single cell organisms to create bacteria. We have the ability to do that now. So let's say that if the carbon dating is correct, ET was on the planet Earth 4 billion years ago, creating bacteria and creating the basic biosphere. And then there's a big, huge gap of about 1 billion years before advanced life forms begin, and those single cell organisms start having a nucleus. And with that nucleus, the witch's ball arises. It becomes information. And with information, advanced life forms start becoming more morphing into advanced life forms. Life creation, ET returns. And when ET returns, we get more advanced life forms. It's great technology. It's not something I'm pulling out of a rabbit's hat. It's just like this. You know, maybe it was in the 1960s, it was just a science fiction story. In the 1980s, it became a reality. Nikola Tesla already set the foundations with a cellular phone back in the 1930s. He died in 1943, so he never saw what his work would eventually become. But he did set the foundations, which is this, foundations to create this. So that's why science has to keep on it. The goal of society and science is to recover what we lost. As I said in my last lecture, Professor had asked a classroom, what do you envision heaven as being? And most of them said Star Trek, you know. Probably because the reasons what is that the transporter Being has the ability to transform matter from one state of existence to another state of existence. And that doesn't conflict with high energy physics. It says there's different stages of matter that you can operate within. It said that the neutrino and the atom, we knew, wasn't the final story, that there has to be another state of matter for their standard field theory to work. So they started coming up with the idea of quarks, and they started coming up with glucons and different, in another state of matter within that universe. So high energy physics is what we study. High energy physics in the 1930s set the foundations for that. That's what gives a society a reason to exist, is creation, recovering what we lost. Let's see, Fermi. Fermi attached decay to his earlier theories also. Fermi modeled that the B decay interaction as closely as possible on the quantum theory of electronic magnetism, quantum electrodynamics. In that theory, the photon, the electromagnetic quantum, acts as a carrier which transmits electromagnetic forces between electrically charged particles. The fact that this quantum has no mass, it was noted, counts the fact that the electrostatic force, that is, Coulomb's law, is what is known as long-range light gravitation. The electrostatic force between two charged points, particles fall off as they inversely square the distance that separates the particles, that is Coulomb's law. Can be derived directly from the proposition that electrically charged particles exchange massless quanta. Now that's something about electrically charged particles. To get what you want, you have to have an outside force, which is creationism. If you want to understand atoms and stuff, you have to create some other outside force to get what you want, which is creationism. So what did they do? They finally, Fermi's foundational theories became an accelerator. And you can take electromagnetism, which creates a field, and you can keep accelerating it, and you can throw those atoms into a plate and watch it explode, and they get some information from it. But it requires a process of creation. It requires an accelerator. It requires an outside force to be able to do that, which is electromagnetism. That's an engineer. So, and all engineering is creation, because you have to be able to utilize what you have out there, and sometimes there's new ideals come up, and you can apply that to applied physics, applied science. Feynman and Robert Oppenheimer discovered, when they went to Los Alamos laboratories, they were out there for a military mission to create a atomic bomb. So they had to take Einstein's E equals mc squared, which is energy, starts out with energy. Einstein was just studying high energy physics back then too, and they had to convert it into a bomb and discover it and figure out how to split an atom, making an atom. And what they found is they have to apply an outside force to make the atom split, which is a point of creation. Recently, they've created a fission reactor, which they can actually control the energy, and they can create a clean form, which is equivalent to what the sun is, and create a clean form, burning form of energy that doesn't give off any kind of radioactive leftovers, which we have to go bury out there for a million years. So it's a lot more cleaner form of energy. I would also question is that the decayed matter in the sun normally is decays, and what the stellar evolutionary theories are is that the sun decays into from going from hydrogen back into helium, and when there's too much helium, it goes into a big giant, and it finally explodes into a nova. But we discover when after the supernova occurs and the neutrinos come flying out, there's a chemical reaction out there that still makes it bioluminescent. Same way with us, you know, we're bioluminescent, so something survives, you know. So there's something out there, it's not just energy, it's also a chemical reaction that's making us bioluminescence plus energy. There's another story out there besides with the sun that we discovered after a supernova, is that it's still bioluminescent. There's something else, there's another part of the story that's missing. All right, let's see. I already told about there's something I found in here that I made a real note of. Okay, yeah, it's in Coulomb's law, and I make sure I can this correct. It's the product of Gell, Mann, and Lowe showed that quite generally the effects of adding all these diagrams to introduce a space-independent electric charge, so that the corrected Coulomb's law takes the form equals 2RR. Moreover, this is the crucial point. This charge gets larger as the distance between the two electrons decreases. And therefore, the force between the particles gets stronger the closer the particles are together above the equation due to the dependence of Coulomb's force. Well, that's ironic because that could also explain the reason why we're bioluminescent, because as you get atoms and stuff concentrated, the atoms, there's an energy, there's a field buildup that also is part of that, and the field increases as you get more atoms close together. So that could possibly explain why we're also bioluminescent, or even why ball lightning, when lightning strikes with the energy and stuff, nucleosynthesis occurs. So when you get extreme high energy and you have it in a round like a witch's ball, all of a sudden you got nucleosynthesis and organic material becomes visible. So I'm not saying that, trying to explain that as being, that might be the energy, but the principles of that might be a possibility. But that is interesting, because it does give an equation as to what the possibility is of what is it that keeps us together as far as atoms go. There's some kind of field that increases as you combine atoms. So that tells part of the story. What it doesn't tell you is what is that acting force that's keeping us, that puts us together. There's some kind of energy infusion that comes together that makes us possible. And it's not something that's very complex. So my next lecture, stay tuned, is I'm going to start covering that, how high energy physics applies to our duration, and how you can't really separate the two, because lightning is actually a part of that. Energy is actually a part of something that ET can use to create life. Well, that ends this lecture.